access to healthy and sanitized water supplies are considered a universal human right by the United Nations. Yet, over 100 water source advisories persist in First Nations across Canada due to contamination risks. Years of government violations and failure to deliver on promises of safe water for remote Indigenous populations have intensified the crisis. The Water Advancement Project promises clean water for everyone. Our proposal entails a modular filtration system featuring flexible components specifically designed to adapt to the diverse requirements of rural communities. The package can be customized to work on-grid or independently for residential and commercial applications. Several innovations have been incorporated to create an affordable and viable alternative to expensive and ineffective conventional filtration systems. Tune in closely for a technical breakdown of this exciting and unique system.
This is an evacuated solar thermal heater. It raises the temperature of the water flowing into the distillation heater, so it requires less energy to boil.
The water distillation heater is primarily powered by the solar panels. The nichrome heating element heats the water and the steam rises into the vents. The steam then moves into the stainless steel condenser coil, which cools the steam back into water using a fan located at the bottom of the unit.
This is the water pump. It produces a max flow rate of 500 gallons per minute by using a 5 horsepower electric motor. The pump casing is made of aluminum and the blades are titanium.
This is an activated carbon filter, used to remove chlorine and foul taste and odor. The contaminated water will enter the filter in one side and flow through the activated carbon, made from raw organic materials, which removes the odor, pollutants, and volatile organic compounds. The treated water then flows through and out the other side of the filter.
For the water mixer, our design has two mixers which will operate in staggered intervals so that one is filling up for the duration that the other is mixing the clean water with minerals. We have decided to add 20 milligrams per liter of magnesium and 30 milligrams per liter of calcium into our water, which will give it a hardness of 157.25 milligrams per liter. This falls well within the guidelines for recommended water hardness and will prevent the water from leaching metals from the walls of the water tower.
This is the water tower. It has a maximum capacity of approximately 75,000 liters, which can provide continuous water to around 230 people on average. This water treatment system can be further modeled into a facility in Minecraft with the help of the mechanism mod. This water source represents the lake or reservoir where the water occurs naturally. There is an electric pump that pumps the water into the facility. Inside the facility, we have a thermal evaporation plant that boils the water and condenses the resulting steam back into clean water. This process removes living organisms from the water but does not completely remove the harmful minerals. The high mineral waste that is flushed from the water tank is sent into a separate facility for further processing, and the clean water is then carried over by this pump through the activated carbon filter that removes the remaining harmful minerals from the water. The water is then put into mixers that mix the water with beneficial minerals like magnesium, calcium, and potassium. Then the water gets pumped up to the water tower where it is stored until someone turns on the tap. Moving back over to the waste pipe, we move over to the waste treatment facility. This will be done by trucks, but in this case the facility is located right beside the water treatment plant for convenience. It is also condensed into a much smaller system compared to an actual system like this one here. The concentrated mineral water is put through another thermal evaporation plant to further increase the concentration of minerals. Then the concentrated waste is sent to a rotary condensator, then a chemical crystallizer, which crystallizes the minerals into powders. In this particular case, the resulting minerals are lithium, lead, nickel, and zinc. A separate process can be employed to make tritium, also known as hydrogen-3, by putting the concentrated waste through a solar neutron activator. Moving over to the last part of the facility, we have the electrical facility that houses the solar panels and the battery banks required to power the entire facility.